Wakil Rektor 2 dan Wakil Rektor 3 Universitas Pekalongan, Direktur Program Pasca Sarjana dan Kerjasama, Dr. Kalimah MM, Dekan Fakultas Pertanian Universitas Pekalongan, Dr. Ubad Badrudin SPMP, narasumber kuliah umum internasional, Associate Profesor Dr. Nazmi Mat Nawi, Bapak Ibu dosen di lingkungan Fakultas Pertanian Universitas Pekalongan, serta mahasiswa dan seluruh peserta yang kami banggakan.
Our distinguished guest, the Rector of University of Pekalongan, Associate Professor Dr. Andikus Hermanto SEMM, the first Vice Rector, the second Vice Rector, and the third Vice Rector of University of Pekalongan, the Director of Graduate Program and Cooperation, University of Pekalongan, Dr. Halimah MM, the Dean of the Faculty of Agriculture, Dr. Ubad Badrudin, SPMP, our distinguished speaker, Associate Professor Dr. Nazmi Mat Nawi from Putra Malaysia University, respected lecturer of the Faculty of Agriculture, and our beloved dear student and all participants.
Puji syukur kita panjatkan kehadirat Allah Subhanahu wa Ta'ala atas limpahan rahmat dan karunia-Nya, sehingga pada pagi hari ini kita dapat mengikuti kuliah umum internasional program studi Pertanian Universitas Pekalongan dengan tema Agricultural Innovation the Malaysian Perspective secara daring melalui Zoom meeting dalam keadaan sehat.
Alhamdulillah, by the grace and blessing of Almighty Allah, we are be able to gather virtually this morning through Zoom meeting to participate in the International General Stadium organized by the Agroteknologi Studi Program Faculty of Agriculture, University of Pekalongan, with the theme Agricultural Innovation for Food Security and Perspective.
Kami ucapkan kepada seluruh peserta, semoga kegiatan ini memberikan wawasan baru, memperluas jejaring akademik internasional, serta di bidang pertanian.
On behalf of the organizing committee, we would like to extend our warmest welcome to all participants. We sincerely hope that today's lecture will broaden our perspective, strengthen our international academic collaboration, and inspire further innovation in the field of agriculture.
Mengawali rangkaian acara, marilah kita bersama-sama menyanyikan lagu Kebangsaan Indonesia Raya dilanjutkan dengan Mars Universitas Pekalongan.
To begin today's event, let us all stand to sing the Indonesian National Anthem, Indonesia Raya, followed by the March of University of Pekalongan.
Kepada operator, kami persilahkan.
Please be.
Kalau kita kok nggak muncul ya, muncul kita ini apa ya? Ini kan nggak.
Kita Sivitas Akademika Unika, bakti kami untuk nusa bangsa. Ku berjanji memenuhi panggilan negara, kesetiaanku untuk Indonesia. Marilah, hai semua, membangun negeri tercinta. Amankan Dharma, perguruan tinggi kita berdasarkan Pancasila, pasti unika dan jaya. Kita Sivitas Akademika Unika, siap sumbangkan daya cipta, menjunjung alma mater dan persaudaraan, membina persatuan kesatuan bangsa. Marilah, hai semua, membangun negeri tercinta. Amalkan Dharma, perguruan tinggi kita berdasarkan Pancasila, pasti unika dan jaya.
Selanjutnya, marilah kita bersama-sama mengikuti pembacaan doa. Kepada Saudara Fakih Firmansyah, kami persilahkan.
Next, let us join together in the opening prayer. We would like to invite the prayer leader, Fakih Firmansyah, to lead the prayer.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah, la haula wa la quwata illa billah, ma ba'd. Para hadirin sekalian, marilah kita menundukkan kepala sejenak dan berdoa. Izinkan saya memandu untuk membacakan doa acara hari ini dengan cara Islam. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamda syakirin, hamda na'imin, hamda yuwafi ni'amahu wa yukafi'u mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karimi wa azimi sultanik. Allahumma a'inna ala dzikrika wa syukrika wa husni ibadatik. Ya Allah, Tuhan yang Maha Esa, dengan penuh kerendahan hati, kami seluruh yang ada di sini mempersembahkan puji syukur kehadirat-Mu. Engkaulah yang pencipta alam semesta ini, Engkaulah Zat yang mengatur alam seisinya, dan Engkau pula lah yang menentukan segala-galanya. Oleh karena itu, hanya kepadamu lah kami berserah diri dan memohon pertolongan. Ya Allah, Tuhan yang Maha Rahim, atas segala rahmat dan karunia-Mu, hari ini kami bertemu di sini dalam rangka kuliah internasional Fakultas Pertanian tahun 2026 untuk meningkatkan mutu kami. Berikanlah kelancaran dalam setiap kegiatan kuantitas kami, dan tambahkanlah curah kasih sayang-Mu sebagai berkah bagi kami menuju ke arah yang lebih benar dan lebih baik di bawah ridho-Mu. Ya Allah, Tuhan Maha Pemersatu, jadikanlah kegiatan ini sebagai momentum untuk mencari solusi dari permasalahan. Berkatkan rasa kekeluargaan, rasa sosial, rasa kebersamaan, rasa persaudaraan, rasa persatuan dan kesatuan antar sivitas akademika Fakultas Pertanian. Jauhkanlah kami dari buruk sangka, percekcokan, perselisihan, dan perpecahan. Ya Allah, Tuhan yang Maha Pengasih dan Maha Penyayang, kabulkanlah permohonan dan doa kami, agar kami semua tergolong hamba-hamba-Mu yang beruntung. Amin, amin, ya Rabbal Alamin. Rabbana atina fid dunya hasanah, wa fil akhirati hasanah, wa qina adzabannar. Wa sallallahu ala sayyidina Muhammadin, wa ala alihi wa sahbihi ajma'in. Walhamdulillahi Rabbil Alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Doa yang telah dipanjatkan menjadi menjadi keberkahan bagi kegiatan kita pada pagi hari ini.
Thank you. May the prayer we have over bring blessings and success to today's event.
Memasuki acara berikutnya, yaitu sambutan dari Dekan Fakultas Pertanian Universitas Pekalongan.
Our next agenda is the welcoming remarks from the Dean of the Faculty of Agriculture, University of Pekalongan.
Kepada yang terhormat Dr. Ubat Badrudin SPMP, kami persilahkan.
It is our honor to invite Dr. Badrudin SPMP to deliver his welcoming remarks.
Matur suwun, izin Pak Rektor. Assalamualaikum warahmatullahi wabarakatuh. Good morning, the Honorable Rector of Pekalongan University, Mr. Associate Professor Dr. Andi Kushermanto SMM, distinguished guest speaker, Associate Professor Nazmi Mat Nawi from UPM Malaysia, who has kindly joined us to share knowledge on this occasion. Esteemed Vice Rectors, Vice Deans, Head of the Faculty Quality Assurance Unit, Head of the Laboratory, Director of PPDK, Lecturers, Head of Administration and Staff, the General Stadium Organizing Committee, and the students of whom I am very proud. Let us offer our praise and gratitude to Allah Subhanahu wa Ta'ala, for by His grace and blessing, we are able to gather here today for this public lecture in good health and high spirit. On behalf of the Faculty of Agriculture, Pekalongan University, I extend a warm welcome and express my deepest gratitude to our guest speaker for taking the time to share insights, experiences, and inspiration with our academic community. Thank you. Public lecturers are a vital part of the learning process in higher education. Through this event, students gain broader perspective on advancement in science and technology, the professional world, and the various challenges and opportunities within the agriculture sector. The knowledge gained is expected, enriching academic understanding, shaping characters, fostering critical thinking skill, and building readiness to face future dynamic. I encourage all students to participate in this event earnestly. Please make the most of this valuable opportunity to engage in discussion, ask questions, and learn from the speaker experiences. May the knowledge acquired serve as a foundation for enhancing your competence and fostering innovation that benefit agriculture development and society at large. In closing, I would like to thank the entire organizing committee for their excellent preparation of this event. May today public lecture proceed smoothly, yield significant benefit, and serve as an inspiration to us all. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih kami sampaikan kepada Bapak Dekan Fakultas Pertanian Universitas Pekalongan atas sambutan yang telah disampaikan.
Thank you very much to the Dean of the Faculty of Agriculture for the inspiring welcoming remarks.
Acara selanjutnya adalah sambutan dari Rektor Universitas Pekalongan sekaligus membuka kegiatan kuliah umum internasional secara resmi.
Our next agenda is the welcoming remarks from the Rector of University of Pekalongan, who will also officially declare this inaugural.
Pada yang Assoc Dr. Andi Kushermanto, kami persilakan.
It is our great pleasure to invite Associate Professor Dr. Andikus Hermanto, SAMM, to deliver his remarks and officially open today's event.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
A very good morning to our distinguished guests, respected colleagues, ladies and gentlemen. Salam sejahtera bagi kita semua. The Honorable Associate Professor Dr. Nazmi Mat Nawi from Universiti Putra Malaysia, Distinguished Dean of the Faculty of Agriculture, member of the academic community, respected lecturer, vice rector, dear student, and all participants joining through Zoom meeting. Since most of the participants today are student and member of the academic community of Universitas Pekalongan, allow me to deliver my remark mainly in Bahasa, so that the message can be received more clearly and meaningfully by all participants. However, with great respect, we warmly welcome our distinguished speaker, Associate Professor Dr. Nazmi Mat Nawi from Universiti Putra Malaysia, and we truly appreciate his presence and willingness to share valuable insight with us today. Hadirin yang saya hormati, pada tahun 2050 diprediksi bahwa populasi dunia diproyeksikan mencapai hampir 10 miliar jiwa. Artinya, tantangan terbesar umat manusia bukan hanya menyediakan pangan yang cukup, tetapi juga memastikan produksi lanjutan di tengah perubahan iklim. Keterbatasan lahan, tekanan terhadap sumber daya alam menjadi sebuah tantangan tertentu intinya. Karena itulah Serikatan Bangsa-Bangsa melakukan zero hunger atau kelaparan yang memastikan bahwa tidak ada kelaparan sebagai salah satu tujuan utama Sustainable Development Goals. Bahkan menurut laporan FAO, hingga saat ini ratusan juta penduduk dunia masih mengalami kerawanan pangan akibat perubahan iklim, konflik geopolitik, serta meningkatnya tekanan terhadap sumber daya alam. Di tengah tantangan tersebut, pertanian tidak boleh lagi dipandang sebagai sektor tradisional. Pertanian hari ini adalah perpaduan antara sains, teknologi, inovasi, AI atau kecerdasan buatan, data, dan kolaborasi global. Ada perubahan paradigma yang sungguh luar biasa. Jangan menganggap remeh pada persoalan pertanian. Justru pertanian ini menjadi salah satu isu strategis, baik isu negara maupun isu dunia. Pertanian bukan hanya sekedar menanam, kemudian hanya sekedar bicara tumbuh-tumbuhan saja, seolah-olah berbicara pada era tradisional, tetapi sekarang pertanian sudah bicara sains, teknologi, inovasi, dan kecerdasan buatan. Hadirin yang saya hormati, Universitas Pekalongan khususnya memiliki tanggung jawab moral tentunya sebagai sebuah pendidikan tinggi yang diharapkan ikut menjawab persoalan tersebut. Universitas Pekalongan yang kita tahu bersama telah mendapatkan akreditasi unggul, memandang bahwa capaian tersebut bukanlah garis akhir. Justru inilah titik awal untuk memperkuat budaya akademik yang lebih terbuka, lebih kolaboratif, dan lebih mendunia. Sebagaimana milestone Universitas Pekalongan yang tahun ini adalah memperkuat fondasi untuk berdaya saing internasional. Bukan kemudian melawan perguruan tinggi yang kuat, tetapi mengambil posisi yang menjadi unggulan di perguruan tinggi, dalam hal ini adalah Unikal, sehingga Unikal ini bisa berdampak dan memberikan makna, baik itu pada skala nasional maupun pada skala internasional. Hari ini kita bersyukur dapat menghadirkan narasumber dari Universiti Putra Malaysia, salah satu universitas terbaik di kawasan Asia Tenggara dalam bidang pertanian. Kehadiran beliau Kami harap bukan sekedar memberikan kuliah umum, tetapi menjadi jembatan ilmu pengetahuan, mempertemukan pengalaman Malaysia dengan potensi besar pertanian di Indonesia. Karena pada prinsipnya Malaysia dan Indonesia memiliki keunikan ataupun karakteristik yang sama, baik itu secara demografi maupun secara geografinya. Kita percaya bahwa ilmu pengetahuan tidak mengenal batas negara. Yang berpindah bukan hanya informasi, tetapi juga pengalaman, budaya akademik, inovasi, dan cara berpikir. Mahasiswa, peserta kuliah umum pada hari ini yang saya banggakan. Saya ingin mengajak saudara semua melihat pertanian dalam perspektif yang lebih luas. Pertanian bukan lagi sekedar menghasilkan panen. Pertanian adalah bagaimana kita menjalankan bumi, bagaimana kita menyediakan pangan yang sehat, bagaimana kita meningkatkan kesejahteraan masyarakat, dan bagaimana kita mewariskan lingkungan yang tetap lestari kepada generasi berikutnya. Itulah makna sustainability. Masa depan pertanian akan ditentukan oleh mereka yang mampu menggabungkan ilmu dengan kreativitas, teknologi, dan dengan kearifan lokal, serta produktivitas dengan berkelanjutan. Karena itu, saya berharap forum ini tidak berhenti sampai kegiatan akademik sehari. Semoga dari diskusi hari ini lahir gagasan penelitian bersama, melahirkan research collaboration, mungkin bahkan joint publication. Dan yang lebih penting adalah mudah-mudahan bisa menciptakan pertukaran mahasiswa dan dosen serta kolaborasi nyata yang memberikan manfaat bagi masyarakat. Inilah makna yang sesungguhnya dari internasionalisasi perguruan tinggi. Bukan sekedar bekerja sama lintas negara, tetapi bersama-sama menghadirkan solusi bagi tantangan dunia. Universitas tidak hanya mencetak sarjana, universitas mencetak penjaga masa depan. Dan salah satu masa depan yang sedang kita jaga hari ini adalah masa depan tentang ketahanan pangan. Akhirnya, saya menyampaikan penghargaan yang setinggi-tingginya kepada Fakultas Pertanian Universitas Pekalongan yang atas usahanya menyelenggarakan kegiatan pada hari ini. Dan tentunya ucapan terima kasih kepada Associate Profesor Dr. Nazmi Mat Nawi dari Universiti Putra Malaysia atas kehadiran berbagi ilmu dan pengalaman bersama keluarga besar Universitas Pekalongan. Semoga ilmu yang dibagikan hari ini mudah dan penerus. Akhirnya, dengan mengucapkan Bismillahirrahmanirrahim, General Stadium Fakultas Pertanian Universitas Pekalongan secara resmi saya nyatakan dibuka. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Atur
warahmatullahi
suwun Pak Rektor.
Ye, Pak Dekan.
Welcome to Associate Professor Dr. Nazmi Mat Nawi.
Terima
Thank
kasih
you
Pak
very
Dekan.
much.
Ya, Assalamualaikum semua.
Waalaikumsalam warahmatullahi wabarakatuh.
Sorry a bit late because I'm having another workshop now, but I skip for a while.
Terima kasih.
Oke. Thank you, Mister.
Terima kasih atas sambutan dari Bapak Rektor Universitas Pekalongan sekaligus membuka kegiatan pada hari ini secara resmi.
Thank you very much to the Rector of University of Pekalongan for
Di Agroteknologi Fakultas Pertanian Universitas Pekalongan secara resmi telah dibuka.
with this, the International General Stadium of the Agroteknologi Studi Program, Faculty of Agriculture, University of Pekalongan is officially declared open.
Hadirin yang kami hormati, sebelum kita memasuki sesi utama, kami akan melaksanakan sesi foto bersama sebagai dokumentasi kegiatan.
To our distinguished guests, before we proceed to the main session, we will have a group photo session for the documentation of today's event.
Kami mengundang Bapak, Ibu pimpinan, narasumber, dosen, serta seluruh peserta untuk berkenan mengaktifkan kamera apabila memungkinkan.
May we kindly invite the Rector, Vice Rector, Director of the Graduate Program and Cooperation, Dean, our distinguished speaker, lecturer, and all participants to turn on their camera.
Kepada operator, kami persilahkan memandu sesi foto bersama.
To operator, please guide the group photo session.
Sudah, Pak?
Terima kasih kepada seluruh peserta atas partisipasinya.
Thank you very much to everyone for your participation.
Hadirin yang kami hormati, selanjutnya kita memasuki agenda utama, yaitu kuliah umum internasional yang akan dipandu oleh moderator kita, Saudara Muhammad Taqwa. Beliau adalah mahasiswa semester 8 yang pernah mengikuti summer semester di Raja Mangala University of Technology, Krungchep, Thailand.
To our distinguished guests, we shall now proceed to the main session of today's International General Studium, moderated by Mr. Muhammad Taqwa. He is an 8th semester student who previously participated in the summer semester program at Raja Mangala University of Technology, Krungthep, Thailand.
Untuk itu, kami persilahkan kepada moderator untuk memperlakukan kegiatan hingga sesi selesai.
The moderator will introduce our distinguished speaker, facilitate the presentation as well as discussion session.
Pada moderator, kami persilahkan.
The time is yours.
Okay, good morning, everyone. Good morning, Professor Nazmi Mat Nawi. How are you today, Professor?
Good morning. Good morning. Very good. Alhamdulillah. Thank you.
Okay. Okay. Before we run to topic of today, let me talk to you guys about the curriculum vitae of our narasumber. It is my great honor to introduce our speaker for today, International Public Lecture. Our speaker is Associate Professor Dr. Nazmi Mat Nawi, who currently serves as the head of the Department of Biological and Agriculture Engineering, Faculty of Engineering, Universiti Putra Malaysia. He's also an associate professor in the same department and has extensive experience in research, academic leadership, and international collaboration. Associate Professor Dr. Nazmi Mat Nawi earned his Bachelor of Engineering in Biological and Agriculture Engineering from Universiti Putra Malaysia in 2005. He later completed both his Master of Engineering and Doctor of Philosophy in Agriculture Engineering at the University of Southern Queensland, Australia in 2009 and 2014. His research interests include agriculture mechanization, post-harvesting engineering, crop sensing technology, and emergency response and planning. Throughout his academic career, he has actively contributed to the advancement of smart and sustainable agriculture through innovative engineering approaches. In addition to his academic responsibilities at Universiti Putra Malaysia, he has served as a visiting lecturer and visiting scientist at the several renowned institutions, including Aussie South Kazakhstan University, Universitas Brawijaya Indonesia, Chanomnal University, South Korea, Atuk University, Turkey, and National Taiwan University. Associate Professor Dr. Nazmi Mat Nawi has outstanding academic record, having published numerous scientific articles in reputable international journal indexed by Scopus. His research span agriculture mechanization, precision agriculture, smart farming technologies, remote sensing, spectroscopy, crop quality assessment, post-harvest engineering, and sustainable agriculture system. He has also successfully led and participated in many national and internationally funded research projects, resulting in several patent, copyright, and innovative agriculture technologies. His expertise has been recognized internationally through invitation as keynote speaker, invited speaker, reviewer, editor, conference chair, and consultant in various international conference and scientific forums across Asia and beyond. Today, Associate Professor Dr. Nazmi Mat Nawi will deliver a presentation entitled Agriculture Innovation for Food Security and Well-being, the Malaysian Perspective. Ladies and gentlemen, please join me in giving a warm virtual welcome to our speaker today, Dr. Professor Dr. Nazmi Mat Nawi. The time is yours.
Thank you very much, Mr. Moderator, for introducing me. A bit lengthy, but actually, yeah, I am just like all of the docent there, still doing research, still doing teaching, and yeah, it's a part of our academic life. Okay, first of all, I would like to thanks to the host, as well as to the moderator, to docent, and then to Bapak Reactor for having time to spend with me today. And also to all of the audience, and maybe we also have international delegates to join this seminar today. Okay, so I am very delighted, very proud to be invited, even though it's a bit last minute invitation, but I know my Professor Ismail is my close friend. I don't want to make him sad. So I say, okay, no problem. I will help you this time. All right. So anyway, currently I am the head of the department. So I have data about what is going on in my department. So today I'm going to share with all of the audience about the agricultural innovation for food security and well-being of farmers in Malaysian perspective. However, my point of view will be based on the technology, engineering point of view. Okay, so this is just an introduction. What is agricultural innovation? You know, innovation is anything, something new, something beneficial that we introduce to farmers in order, the first one is to get a better yield, to reduce the production cost, as well as to get the to adapt some quality to the value. So on my side, from engineering perspective, we are working on sensors, we are working on the IoT, machine learning, how to make that things more valuable. So if you go under the innovation, the most common term for agriculture is precision agriculture. So later I will describe what we have done in Malaysia. This is about how we apply the right amount, the right time, at the right place, at the right dosage or form of any chemical substance to the crop. And then recently, our department, also in UPM, we have ventured into the use of AI, artificial intelligence, machine learning, and etc. I will share with you later. And then genomic editing, we have one Institute of Plantation Study, who have their own, we call it research group, who are focusing on that. And then automated farm equipment. This is where my research team is working on. We develop a lot of equipment, automatic, and then some of them are autonomous to be used in the field. Okay, so as an introduction, first of all, because we in agriculture, we have to know what are the current technology available for agriculture. This in our traditional practices. Okay, so basically I can conclude there are four type of latest technology that is suitable for agriculture. The first one is mechanization technology, and I believe this technology is the fundamental. Everywhere we go, we will see the use of tractors, the use of implement, the use of four-wheel drive. They are classified as a mechanization technology. Okay, and then number two is the automation technology. Is a bit one step ahead on top of mechanization technology. Say for example, previously we have a car, sedan car, manual transmission, but now we have automatic transmission. Okay, so it will give a better experience to driver. And then the third one, this is quite catchy. It's a bit, I mean, everybody is rushing, is going into that, have an interest. It's a robotic technology. Okay, so my department or my university spend a lot of effort on this area. So robotic technology, I also believe, because I have many colleagues, many collaborators from Indonesia, they also work on robotic. So we can divide robotic into two groups. The first one is UAV or drones, unmanned aerial vehicles, and then the second one is UGV, unmanned ground vehicles. So ground vehicles refer to like autonomous. If you look at this photo, the photo next to it, this is what I mean by UGV. Still using remote controller, but that machine can be maneuvered by itself. Okay, either we use remote control or we can put on the mapping by GPS. Okay, and then the fourth one is a smart farming or precision technology, and I believe in Indonesia, they are also advanced in the precision agriculture technology, where they use smart farming a lot. And then I visited a few universities. They even have plant factory in campus. So it shows that the technological literacy in Indonesia is also high, right? Then I just put the AE. AE means agriculture engineers, but in our perspective today, maybe we can say what can all of us do about this? What can, because I'm not sure about your program, but I believe it can be science, agricultural science or agriculture engineering, but again, we are all in agriculture domain. Okay, then again, another terms is where can IR 4.0 fit this technology? Because if we have a smart farming, we have drone, we have sensors, we have IoT, but if it doesn't fully utilize the existence of IR, industrial revolution technology, it doesn't really go far. So later I will share how we can fully utilize the presence of IR 4.0 to further advance our research. Okay. Again, this is just a review. Food security. If you talk about food security, it's about how people have reliable, have confirm access to sufficient, enough, cukup makan, and then the food is safe, nutritious, ada khasiat, and active, for active and healthy life. Okay, if you eat rice is a good quality rice. If you have an access to drinking water, it is potable water, clean water. Okay, and then as which individual have physical and economic access. So meaning that everyone is able to buy. Everyone is able to buy, to have access to rice, for example. Okay, but maybe it's a bit different if you talk about durian, for example, or cocoa. It might be selectively for rich people, but for basic food, it has to be accessible to everyone. Okay, and then there are four pillars of food security, availability. So this is the issue later I will share, but I would say that how do we measure the availability? One of the criteria is we look at our SSL level, self-sufficiency level. So for example, in Malaysia, referring to rice, previously our SSL is 80%, meaning that the local farming can only support 80% of the demand of rice in the country. So the remaining 20% we have to import from neighboring country, from India, from Thailand. Okay, I'm not sure in Indonesia, but I think you have, I believe, I heard somewhere you have reached 100% SSL, and then some country they have excess. They produce more than what they need, then they can sell. Okay, but sadly, recently, due to the urbanization, due to weather change, climate, so our SSL in Malaysia has reduced to 60%. So we have to import more to top up the need of the rice in the country. So we are not in good condition. So the government has done something to make sure our access to food, our staple food, rice, is always guaranteed. Okay, and then access available is number one, and then access, as I said earlier, everyone should has an access. So if a staple food is too expensive, then poor people cannot afford. Okay, so then the government has to do something to make sure there is a control mechanism so that rice is accessible, chicken is accessible, whatever, eggs, telur is accessible to all the people. And then in terms of utilization, it has to be utilized for the healthy diet and also for stability. The supply is consistently available throughout the year. Okay, it's not like, for example, durian is a seasonal, but for staple food, it has to be available throughout the year. Okay, because we eat rice every day. So in Malaysia, I will say that I eat 3 times a day, morning, lunch, and dinner. Okay, so again, I will talk about, because in my field is agriculture engineering, where in this discipline, we really emphasize the student to look at the innovation, how engineering technology can be used to create something, to innovate something for the betterment of the farmers. It may involve design of a new product, develop a new structure, to innovate the existing product to be better, achievable, cheaper, right? And then again, when we talk about engineering, it's not just about producing things, but it has to produce things that is affordable, functional, simple, and it meets the economic of the operation, sustainable, and does not jeopardize the health and safety of the operator. Okay, so again, sorry if this is not really related to your program, but I believe we all appreciate agriculture engineering. Even in UPM, we have Faculty of Agriculture. They have Department of Agricultural Technology. So agricultural technology is just a bit, just one step below than agriculture engineering. Okay, but this is what we do similar. I also teach my student about machinery, how to grow corn, soil manipulation, soil testing, soil fertility, harvesting, how to do drying, sorting, etc. Okay, and then we also include, because we are talking about innovation, so innovation have to use existing modern technology, which include modern sensors, if you know Arduino, microprocessor, and also all this process can be categorized as digitalization. Previously, if we use pen and paper to record the growth of the crop, nowadays we do not use that anymore. We just put a camera, we just put a sensor, we just put whatever, then that sensor collect the data for us. Everything is digitalized, everything can be analyzed on time with the help of machine learning. Okay, so you see how the technology, the monitoring process in agriculture is developing, and we at university, we provide, we train our students, we train the farmers, we help industry to make that happen, so that the farmers, the company can use the technology. Okay, so I'm not going to read through, but that is a part of our commitment or our role as a agricultural engineers for the country. Okay, and then okay, this is just a bit sharing where this is research area or working, and where my student will work when they graduated. They can serve as agriculture engineers in any company, wastewater, bioprocess, and etc. Okay, and then there is a demand. It's not just for agriculture engineers, but also for agricultural graduate in my country. So the demand is there because the government is spending extra money to support any agriculture project like giving grants, etc. Because we are concerning about food security. Okay, especially now is because of war, and also because of the fuel price, fuel increase, and also climate change, some area that was stable before suddenly got hit by heat wave. That lot of uncertainty that we have to deal with. Okay. All right, now come to the agriculture production. I believe dosen-dosen yang dekat in this university have better knowledge in terms of your local crop. You may know better because if you are in agronomists, right? Because I am engineering, we usually work with agronomists, we work with farmers, with botanists, with expert on disease if they need technology like for detection, for rapid spraying, etc. Okay, so basically in Malaysia, food we can divide into two. Okay, we have food crops, something like rice, vegetables, tubers, fruits, and etc., and which dominantly grown by smallholders. All right, and then we also have industrial crop. This usually belong to big company. For example, oil palm, rubber, tea, cocoa. You call it cow, right? And then and many more. Also pineapple. Okay, but again, if we look at both crop, the issues are the same, similar. Okay, they have a problem with volatile prices, depends on supply and demand. Sometimes the demand is high, so you can sell at high price, and then when the demand is low or supply is more than demand, the price will be low. For example, currently Musang King, we have the top brand of durian in Malaysia, Musang King, where a few years ago it was sold at 100 ringgit per kilogram. Per kilogram,
For
but now because of the oversupply, everybody planted Musang King, and now it only sold at 20 ringgit per kilogram. So the farmers might lose in terms of pricing. Okay, there is a prices and depends also supply from demand from overseas. We used to sell our durian to China, but lately China also got supply from Vietnam and from Thailand. So we have to compete, then the price is dropped. Okay, but there is one example. And then unfavorable market outlook, disease. This is one of my research area. Early disease detection. We use spectroscopy, we use any sensor to detect disease at the earliest stage so that we can do some effective prevention. Okay, we can go for NDT, non-destructive testing, either using optical sensors or image remote sensing. And then fertilizers is also part of our concern because the price of fertilizer globally has increased. So we have to apply fertilizer at a very optimum cost, a very optimum amount. Okay, we cannot waste. The same thing with pesticide. So variable rate technology system. So when we supply fertilizer, we supply only the needed dosage by the crop. And then again in Malaysia, the majority of farmers are elderly or orang tua. So they cannot do anything as like when they were young. So there is the need for mechanization and automation. But in Malaysia now, farmers very rare. They do not own machinery, but we have many third-party service provider. So this third-party or service provider, some are run by young people who just graduated from university. So they set up a company. So they provide a service to farmers. This is good way of doing things. Okay, and then we also have a problem with small scale production because Malaysia is just small country. Later I will show you the statistic. So we have a problem with arable lands. So nowadays we have a technology of soil mapping. Okay, so then we know which soil is okay, which soil is not. Then we can propose for treatment, rehabilitation. And then limited technological adoption. This is also our role. AE mean agriculture engineer. This is for my student. I challenge them. I said, you are the change agent. When you graduate, you have to go to see farmers, to involve with farmers and bring in the technology that we have on the market. And many more, scarcity water resources due to climate change. Some area that never have flood problem, lately they have flood problem. So many things we have to consider, and a rapid urbanization. So we go for urban farming and etc. All right. So this is the main crop in Malaysia: rice and oil palm. Okay, rice for our staple food, our security, and oil palm is our golden crop for business. So total acreage for rice, we have 600 tons, 600 hectares. Okay, while for oil palm, it go up to 5 million hectares, roughly, and on average. And then this is fact and figures, and you see how many workers involved. For paddy field is about 200. Is almost 100 workers, and then for oil palm is about 500 workers. Okay, 500,000 workers involved in the oil palm, right? So there is the demand for manpower. But again, we cannot always rely on a labor, because we learned a lesson learned from COVID last time. When the COVID happened, the border was closed, so we have a problem with labor shortage because the foreign labor wouldn't come in due to the we call it the closure of the our international door, our immigration. Okay. So therefore, based on that incident, the company, the estate company, has taken so much innovation. They have invested in a lot into machinery. Then they have come out with a policy that if before the average labor to land ratio is 1.1 to 8, meaning on daily basis or yearly basis, one workers is responsible to look after 8 hectares. This is before fully mechanization. But by 2025, last year, through mechanization and automation, so the company has increased. So instead of one workers to look after 8 hectares, now they want one workers to look after 12 hectares. So means that workers is provided with like ATV, like a tractor, so they can maneuver in the field easily. Then it was assisted with a lot of tools and equipment. Okay, but again, that's not enough. Later, they are still planning, they are still investing more on the machine. So by 2023, 2030, they aim to further reduce the number of workers. They increase the worker efficiency. So one worker will look after 15 hectares. You see, with the help of technology. Okay, so in Malaysia, all of those innovation is supported by the government because our government has a policy, national agro-food policy. And then if you see there, one of the component under that policy is to increase the use of automation and mechanization in plantation, in farming. Then for this to happen, my department with my colleagues and also UPM as a whole also play an active role to support the implementation of this initiative. Okay, so what is the problem with agriculture actually? So if you look at in the global perspective, farmers, if this is for the world, farmers only represent roughly 5% of the world population. This is active farmers in the world, okay, even in the US. So the problem is with these 5% farmers, they have to feed the whole entire population in the world. Okay, we exclude the small scale farmers. Okay, and then in Malaysia, we have now 34. This is 32 million to 3 years ago. So we have 45 or 44% are youth. Unfortunately, only 15% out of this 45% youth involved in the agricultural sector. So they still have a sentiment that doing agriculture is not good. Doing agriculture is still have a 3D sentiment, like difficult, dangerous, dirty, panas, work under the sun. And then if you go to oil palm industry, it might expose you to the snake, to babi hutan, wild boar, and etc. So they prefer to work in the shopping mall where with the air conditioning condition, right? But now we are trying to change that paradigm. We are trying to say that even if you work as agriculture, in agriculture, you can work in an office, so everything can be monitored remotely by using sensors. Okay. So there are three components that we have to modernize if we want to attract more youngsters to join agriculture. The first one is mechanization. We have to invest appropriate mechanization. It's actually, if you talk about mechanization, mechanization comes with different sizes, different functions. So engineers or you as an agriculture officer have to choose the right one so that it can be run at optimum cost. And then automation, and then I think for automation recently it's not really issue because most of our local fabricator can do. Okay, we can if you want to add some pneumatic parts or something that can be done locally. We have many designers. And then digitalization is how we use sensors. This is nothing new for I mean, especially in Malaysia, even in Indonesia, I see that because most of the graduated student, they learn basic coding, how to integrate light sensor, humidity sensor, and etc. So that can be used to monitor the crop, also to control the irrigation for greenhouses and etc. So this is what I would say the developing knowledge, developing technology in our country, in our both countries. Okay. One part that developed so well in Malaysia is mechanization. I would say that 100% or 99% of our paddy field is mechanized. So no one is using buffalo anymore. No one is using two-wheel or push type two-wheel tractors. Everyone, they use four-wheel tractors. Okay. Also for harvesting, we use combined harvester. So that can increase the yield and also reduce dependence on general labor. Okay, so mechanization is a process how to replace mechanical power to replace human and animal power. Okay, so see this example. I'll show the progression of mechanization in oil palm. So initially, maybe 20 years ago, we use buffalo. You see the first photo, we need one buffalo, kerbau, and then we have oil palm, then we have a trailer, we have two workers at the back. One to stick, to grab, untuk dipanggil pancang untuk cucuk dia punya FFB, fresh fruit bunch, put into the trailer. So you see the second photo, it's heavy. I think it's typical in Malaysia. One bunch, satu bunch itu, the weight of one bunch is around 30 to 50 kilogram. Now one bunch. And then recently, I think maybe 10 years ago, we have modernized the system from using man to upload the FFB. From using buffalo, we replace with tractors. And then for picking up the FFB, we use grabbers. You see that yellow hydraulic grabber. So I would say that 80% of our farm in Malaysia now, they are using this grabber. Okay, but it doesn't stop there. Okay, what is next? What is next is happened. We have a project with one big company. 2 years ago, we have started. So that company want us to, you see now, the driver, whenever they see FFB, they have to stop. They have to stop the tractor and then they kena toleh, kena pusing kepala untuk nak tengok either the grabber directly pointing to the right place to grab the FFB. But nowadays, what we do, we have attached a camera. We have attached a camera to the grabber, so the grabber will find FFB by itself. So the driver just keep sitting on the seat, look forward, look to the front, and the grabber will work. Will find the FFB by themselves and then grab and put into the trailer. Yet it doesn't stop there, because the mission is the company said later now they have one driver. So they said later we don't want a driver. We want that tractor to move autonomously. So whenever they spot any FFB at the roadside, the tractor will stop, the grabber will work using the camera, and then it will keep moving. That is the mission of that company that we are working on. Okay, and this is the evolution of spray pesticide. No, this is fertilizer application. You see, manually we use wheelbarrow, manpower. You see that even without wearing glove. Okay, use a pail, use a protein, kan? And then we introduce machine. So the first photo show a spreader machine for granular fertilizer, for rubber wheel, and then the second photo shows the same spreader, but in Malaysia we have a problem with pit soil, tanah gambut, tanah lembut. So for pit soil, the tractor with tire cannot go in. It will be slippage. Okay, so we change from tire to rubber track. So you see this photo, the same body chassis spreader but attached with track, with a rubber track. But it doesn't stop there. Recently, 2 years ago, I visited one company. They have started using the tractor with variable rate fertilizer applicator, meaning whenever they do not go for blanket application anymore. So the spreader, the fertilizer will be supplied according to the amount that is needed by the tree. So this is what is happening in Malaysia. Okay, and then this is some of the technology that even a tractor can be changed into the undercarriage system. On top of putting a rubber wheel, we can modify to use like rubber track to increase traction for paddy field. So this is what we have in Malaysia now. You see the first photo is a rubber wheel, but local farmers have changed because they want to increase the flotation, increase the traction. So they have changed the rear tire of the tractor with a steel track, a half track tractor. So it works. And then since then, a few company has introduced a triangular rubber track, and this is the new rubber track rotary tiller. So in our country now, this machine is getting more popular, okay, because it proves it can, we call it flotation. Okay, it can maneuver better in a paddy field. Okay. This kind of factor for mechanization, later if you want to adopt mechanization, this is the component that you have to consider. Yeah, we need to have a good farm infrastructure, especially for parking, a garage, a turning point. And then, as I said earlier, if you talk about machine, if you talk about tractor, it doesn't fit for all. Okay, you must select the right tractor for your intended crop. Because we have to consider over and under power. Okay, some tractor was designed for heavy utility, medium utility, light utility. Okay, and then the sizing, horsepower selection, implement tractor matching, all those things can be done by agriculture engineers. They also have to look at the terrain, the soil type. Either it will be used on the clay or pit soil, so it required different tire condition, right? Well-trained people, and then maintenance, either you go for preventive or corrective, and then management with positive mindset, because it is common for using machinery, it involves high capital costs, but the running cost for the next 5 years will be low. Okay, that is common. Okay, and I have a story one day, 3 years ago, I think I was invited by one company to design lemongrass serai, lemongrass harvesting machine. So I went to the field and I talked to one farmer, old farmers. He was, at that time, he was digging, menggali serai. Then he asked me, Nak, what are you doing? Anak buat apa? So I said, I am collecting data because I'm going to design a new implement for lemongrass harvesting. And then suddenly, immediately, he said, oh, nanti, he just said that he afraid when the machine is materialized, he will lose his job. He said, oh, nanti pakcik tak ada kerja lagi. Right. So there is a demand. There is the thing that the machine will certainly replace workers. But that what we want in Malaysia, because we don't have enough laborers to work in the field. But in some countries, I think in some part of Indonesia, they still need to maintain workers, right? A few years ago, I went to Surabaya, I went to Malang. From Surabaya to Malang, it was a paddy field, okay, in the way. And I saw farmers there still manually digging, menggunakan cangkul, ya. Then I asked my host, why these farmers still using manual, didn't use tractor? Oh, he said, no, if we bring in tractor, then that man has no job. So meaning you have to consider social factor, social impact, social economy before you go for modernization. So if that is true, let's say, okay, let's say. But in my country, in Malaysia, we don't have enough labor. So we have, by hook or by crook, we need to go for a machine. Okay. So this is, I'm not sure how long the time I have, Mr. Moderator. Should I stop for Q&A or what time I should stop?
Okay.
What time I should stop? Maybe I can allow 10 minutes for Q&A. Okay, how long? How many times I got to finish?
Okay, Professor, we have 2 sessions for Q&A. The time is around, yeah. Okay.
Maybe I can stop. I can share for another 5 minutes. I will stop at in my time 11:20. Then we'll allow for Q&A for 10 minutes. Okay.
Okay, for 10 minutes.
Okay.
Yes.
All right. So okay, this is our local technology that we developed by university professors. We can build, we can design a machine which is needed by the industry. We have that capacity, and this is all the machine developed by our own talent, Malaysian Palm Oil Board. So we have a team of designers in Malaysia, in university, also in Malaysian Palm Oil Board. So I think in Indonesia it might be similar to BRIN or something, penelitian, research center. Okay, so you see different type of machine designed, developed by our local talent. Okay, this is if you want to buy a machine, make sure you have to buy from a company that have this 4S. They have a showroom, they have a sales, and also after sales service, they also supply spare part. If not, when the machine get broken, breakdown, then you cannot do anything. Okay, it will be something to write off. Okay, and then we also have started introducing sensors technology. This is for precision agriculture, IART 4.0, the use of IoT internet so that we can monitor whatever happen in the nursery, in the farm, far away from our office. Okay, I think this is quite generic. You can go through, and then one of the example of the application of IR 4.0 is this photo was taken from Japan, Tsukuba University. I visited the university 2 years ago. So how they have designed, they have built a connected tractors, unmanned tractors, okay, autonomous tractor using machine. So means inside the tractor, they don't need a driver. They just control the driver either using programming or using joystick, okay. And then again, digitalization, as I said earlier, if we fully utilize digitalization, we don't have to hire somebody to go to measure our crop growth every day. Okay, we only put a sensor, whatever sensor, then everything is recorded and sent to us that we can monitor from our desktop. Okay, this is about IR 4.0. They have many pillars technology. It doesn't, because somebody asked me what is IR 4.0. I said for IR, Industrial Revolution 4.0 is not the technology itself, but it's an era, zaman. It's a time frame. It's a domain. So we are in that domain now, where under this era, we have all this technology. Okay, we have autonomous robot, we have Internet of Things, cloud computing, and many things. And then we don't have to use all of them. So I think for agriculture, we might need artificial intelligence for monitoring. We might need autonomous robot for drone and etc. Cloud computing, but we don't need like advanced material, cyber security. That is, to me, for agriculture, we don't need that because it's nothing to do with security for now. Okay, all right. Okay, I will go quickly, but this is example with what we have done. 4.0 technology. It's again, 4.0 is the era where we are now, where we have an access to smart sensors, low cost sensors, microprocessor, and etc. This is a greenhouse plant factory. Last time I visited UGM, University Gajah Mada, they have one unit of plant factory in Yogyakarta. Yeah. Okay. Again, the technology comes with challenge, and the first one is hardware. We have to buy reliable hardware, because for those who are working in the field, in the manufacturing, they are under control environment. But when we go for agriculture, our sensors, our processor will have to put outside, exposed to weather and etc. So it has to be reliable. The brain is where, the microprocessor itself, the people, we have to train more people who are good at programming, electronic part, okay, mobility, and also infrastructure. And then to support the use of sensors in rural area, we have solar technology, okay, to provide power for remote area. Okay, this is a way forward for agriculture. So I encourage all of you, the students who are listening to me now, you can invest yourself in any of this technology. Be good at any of this technology, because it will be the future for agriculture. Okay, automatic, smart sensors, IoT, and etc. All right. I think, yeah, this is when we want to introduce any new technology, we have to look at the field performance first. Can it be better than a manual performance? If manual performance is better, then forget. The technology doesn't work. And then cost, it has to be reasonable, affordable, and then safety to handle for people. Okay. So this is my research area, my research expertise. I work on machine design, testing, and etc. I also work on sensing, crop sensing. Okay, so do the testing for crop maturity, early detection of disease, and etc. Okay, and then this is one new things in Malaysia. We have ventured into electric tractor. So because oil palm has an issue with carbon footprint. Okay, one company came to see me. They said, how can he do something with carbon footprint? Because in Europe, they're concerned about that. They say something not good about Malaysia, Indonesia, I think, because we produce carbon, etc. So we will try to counter that one with the use of electric tractors. Drones is everywhere. This is our ongoing, but I think I will skip this one. This is for grain monitoring. Yeah, for food security, we have to produce the best of the yield by reducing the yield, the grain loss, because at the field, grain loss can be up to 20% in Malaysia. So we have developed a system. By having this system, the driver of the combine will monitor any losses happen, then it can be controlled to reduce to only 5%. Okay, this is the project. This is also one innovation my team has commented. I presented this with Prof Ismail last time about our new product on a biofertilizer based on siput kondang, snail-based liquid foliar fertilizer. And this is also IoT project under my team. I go quickly some of this innovation because the title is about innovation. This is what we do in at university level. Many more. This is for IoT. Okay, so I think we come to the end. We have maybe 10 minutes for question and answer. So I leave it. I pass it back to Mr. Moderator. Thank you very much.
Okay, thank you, Mr. for the presentation. And yeah, we run through the question and answer session. We have two sessions for the Q&A. Okay, to everyone who wanna ask for Professor, please raise your hand first and then open your camera and open your microphone. Okay, we have the Ichiro Yanuari Trikajen. The time is yours.
So for before that, I'm sorry if my English is not good enough. I have question for Professor Dr. Nazmi Mat Nawi. So before I ask my question, allow me to introduce myself. My name is Ichiro Yanoro Trigacher and I'm in the Faculty of Agriculture at Pekalongan University. Many modern agricultural innovation such as drone or IoT-based soil sensor require very high initial investment cost. So, what is Malaysia's strategy to ensure that these innovations are not only enjoyed by large corporations, but are also inclusively accessible and actually adopted by small-scale farmers? Thank you.
Okay, thank you, Mas Ichiro. Good question, and I think I always receive this question everywhere I go. Okay, but in Malaysia, there is an initiative by the government to provide a grant, for a new company, and then those who graduated from university, if they want to be an entrepreneur, there is also a support from the university or from the government. But again, I want to put you in this perspective. The capital cost for buying drone is not maybe expensive, 40,000 ringgit in Malaysia, so about $10,000. But the profit you can make. So one of our student, after finishing study, he created a company spraying, a drone spraying company. He said after 2 seasons, he get back balik modal. We call it break even. So even though he invested, maybe he purchased 3 to 4 units of drone, but only after 2 seasons, 2 growing season, he get back the profit. I mean the break even. So don't be afraid with the capital cost. If you do your business right, the profit will come to you. Maybe after 2 years, 1 year. Okay, but in terms of assistance, yes, our government, even university, we have a program. We call it a program to grow our graduate student. Also, the government also have a grant to support a new company in this agriculture. But again, even though capital is high, but you can make profit within 2 years. And if you are a farmers, you don't have capital to buy drone, for example, you go for service provider. In Malaysia now, there are many service provider who provide spraying service, tillage, combine harvester, and etc. Okay, I hope I answer your question.
Okay, thank you, Professor, for the answer. And for everyone who wanna ask, please raise your hand again. We have Salman As-Sauri. Dipersilakan.
Okay, sila.
Halo, good morning. Saya pakai bahasa Indonesia aja, Pak.
Boleh. Bisa. Paham.
Oke. Mengingat Perkenalkan, saya Abrao. HP saya gak bisa digunakan, jadi saya pakai punya teman saya, Pak.
Oh, okay.
Mengingat Indonesia masih menghadapi keterbatasan dalam akses teknologi, infrastruktur, dan kapasitas sumber daya manusia. Menurut Bapak, teknologi apa yang dibutuhkan untuk bisa membantu para petani? Karena kita lihat bahwa para petani yang kurang punya pengetahuan terkait pupuk itu, kadang mereka pupuknya itu lebih jadi membuat tanah yang awalnya produktif itu jadi tidak produktif, Pak. Nah, dari sini muncullah bahwa teknologi apa yang kita butuhkan untuk bisa membantu para petani, Pak.
Oke, itu saja. Itu saja soalannya. That's all. Okay, so saya jawab ya. So kalau tadi Mas cerita pasal tanah, soil fertility, and then so I would like to answer in two perspective lah. The first one, university can play a role to come and do the investigation about the soil fertility, like we call it community service, and then suggest to farmers what kind of soil rehabilitation suitable for that land, because tanah ini lahan, if you expose to common or similar for many cycle, then it will affect its fertility. And then secondly, there is a service, there is an opportunity in my country. My friend, he run a company, he has a soil mapping soil mapping technology. So farmers will call him. So he provide a service to do the mapping. He use a sensor, soil mapping sensor. Then he run his machine, he sees sensors, and then he produce a map. He can tell the farmers, okay, Pak Cik, Mak Cik, Bapak, tanah di sini perlu lebih kalsium, tanah di sini perlu lebih nitrogen. So with that mapping, farmers can take action to rehabilitate, untuk memulihkan tanah. Okay, jadi two option. Either any of your student can be a company owner, to maybe you will be the first in Indonesia to offer that service, do soil mapping, and then the soil can be dipulihkan mengikut keadaan. That is the first. Dan yang kedua, if there is no company who are willing to do that business, then university can take the initiative to like a community service to do the testing, to promote the technology. Sooner or later, that technology will be on demand. The thirdly, I would suggest university or any government officer to work together with China, with Malaysia, maybe with Japan, who has that technology, so they can come for promotion. It will be free for the beginning. That my thank.
Okay, thank you, Professor, for the answer. I want to tell you, Professor, that Mr. Abrao is student from Timor-Leste who get a scholarship from University of Pekalongan in Faculty of Agriculture, right?
Okay,
So,
very good, very good. Yeah.
any question? Again? Anang Ibnu Pangestu, please open your cam and yeah.
Halo, oke. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Allow me to introducing myself. My name is Anang Dumaestu, sixth semester student majoring in Agroteknologi at the Faculty of Agriculture, Pekalongan University. First of all, I would like to express my gratitude for the opportunity to ask a question. Please excuse me, Prof. I would like to ask something.
Okay, go ahead, no problem.
With the rapid advancement of GIS and remote sensing technology, soil mapping has become faster, more efficient, and capable of covering extensive arrays. To one extent, do GIS and remote sensing contribute to soil mapping? In addition, how can soil mapping output be applied to support agricultural practice such as land management, crop sustainability assessment, and productivity improvement? That is perhaps what I want to ask. Please excuse my imperfect English. Thank you, Professor.
Okay, that's all.
Terima kasih.
Okay, sama-sama. So the question is how GIS mapping, I would say mapping can be used for how extensive that one has been used for soil mapping in Malaysia. Okay,
Yeah.
GIS or it attached with GPS for mapping or remote sensing is a very general tools. Okay, it can be calibrated against anything. It can be calibrated against soil. It can be calibrated against the soil. I mean the crop fertility, NDVI, and etc. But if you look at how extensive the use of soil mapping in Malaysia, I would say that it is growing because in Malaysia we have issue with barren soil. Kami punya lahan, kami punya tanah, because we used to grow only one crop over the year, so tanah menjadi tidak subur. So by right we have to do intercropping kan, tanam padi, nextnya tanam kacang, so the nitrogen will be absorbed back to the soil. But because we have monotomous system, so the soil become weakened, barren. So the government has taken initiative to do soil mapping. The plan is to do the mapping for the whole country. So you see the demand, how extensive it is used. It is for the whole country, for the nation. But they do that step by step. So I mean that machine, the system has been done in a few places because we have limited. Okay, but there is a demand. So the national plan is to do the soil mapping for the whole paddy greenery areas in Malaysia. But it has been started plot by plot, but long way to go, but there is a demand. So one day in the future, we will have the soil mapping for the whole planting area, paddy planting area in Malaysia. That is my response.
Okay.
Okay.
Thank you, Professor. Any question again from? Okay, I think no one. Okay. Let me take the conclusion for this discussion, Professor. Okay. During this session, we gained valuable insight into the strategic role of agriculture and biosystem engineering in supporting food security through the application of engineering principle, mechanization, digitalization, automation, land and water resources management, and the development of post-harvest technologies. This integrated approach aims not only to enhance agriculture productivity, but also to establish farming systems that are more efficient, sustainable, and environmentally friendly. Thank you, Professor. So very insightful for this discussion today. Thank you for your participating.
Okay, you're most welcome. And if you have any further discussion or question, you can email me at my email address. Okay, no problem. I'm happy to share, happy to help. Okay, thank you very much for all.
Dok, mohon maaf dok.
Terima kasih kepada moderator yang telah memandu jalannya kegiatan, serta penghargaan yang setinggi-tingginya kami sampaikan kepada narasumber Asosiat Profesor Dr. Nazmi Mat Nawi atas materi yang sangat bermanfaat dan inspiratif.
Thank you to our moderator for facilitating today's session. Our sincere appreciation also goes to Association Professor Dr. Nazmi Mat Nawi for the insightful and inspiring.
Telah disampaikan memberikan manfaat bagi semua.
We hope that the valuable knowledge shared today will greatly benefit to all of us.
Hadirin yang kami hormati, selanjutnya adalah prosesi penyerahan sertifikat penghargaan kepada narasumber sebagai bentuk apresiasi kepada kesediaan berbagi ilmu dan pengalaman pada kegiatan kuliah umum internasional ini.
Ladies and gentlemen, we now proceed to the presentation of a certificate of appreciation to our distinguished speaker as a token of gratitude for sharing valuable knowledge and experience with us today.
Kepada operator kami persilahkan.
To the operator, please proceed.
Hadirin yang kami hormati, sebelum kita menutup acara ini, kami akan melaksanakan sesi foto bersama sebagai dokumentasi kegiatan.
To our distinguished guests, before we proceed reach the end of the day, we will have a group photo session for the documentation of today's event.
Kami mengundang Bapak Ibu pimpinan, narasumber, dosen, serta seluruh peserta untuk berkenan mengaktifkan kamera.
May we kindly invite the Rector, Vice Rector, Director of Graduate Program and Cooperation, Dean, our distinguished speaker, lecturer, and all participants to turn on their cameras.
Kepada operator kami persilahkan memandu jalannya sesi foto bersama.
To the operator, please guide the group photo session.
Oke, kameranya dinyalakan ya. Saya screenshot 1, 2, 3. Gen 1, 2, 3. Gen 1, 2, 3. Lagi-lagi 1, 2, 3.
Terima kasih kepada seluruh peserta atas partisipasinya. Hadirin yang kami hormati, sampailah kita pada penghujung acara Kuliah Umum Internasional Program Studi Agroteknologi Fakultas Pertanian Universitas Pekalongan.
To our distinguished guests, we have now reached the end of today's International General Studium.
Kami mengucapkan terima kasih kepada Rektor Universitas Pekalongan, Direktur Program Pasca Sarjana dan Kerjasama, Dekan Fakultas Pertanian, narasumber Associate Profesor Dr. Nazmi Mat Nawi dari Universitas Putra Malaysia, moderator, seluruh panitia, serta seluruh peserta yang telah berpartisipasi dan menyukseskan kegiatan ini.
On behalf of the organizing committee, we would like to express our sincere gratitude to the Rector of University of Pekalongan, the Director of Graduate Program and Cooperation, the Dean of the Faculty of Agriculture, our distinguished speaker, Associate Professor Dr. Nazmi Mat Nawi from Putra Malaysia University, the moderator, the organizing committee, and all participants for making this event a success.
Apabila selama memandu acara terdapat kekurangan maupun kekhilafan, kami mohon maaf yang sebesar-besarnya.
We sincerely apologize for any shortcomings or mistakes during the course of today's event.
Akhir kata, wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much for your kind attention. Have a wonderful day, stay healthy, and we look forward to seeing you again at our future event.
Selamat siang dan sampai jumpa pada kesempatan berikutnya.
Good afternoon and see you next time.
Matur suwun Bapak Ibu
Oke,
semuanya.
matur suwun Pak
Ah,
Dekan. Sukses ya Pak
Nuwun,
Dekan.
amin
Alhamdulillah.
amin, alhamdulillah. Sehat sukses semua nggih.
Keluar ya Pak Dekan ya.
Nggih.